So down to a paltry 2 screens. Alrighty. So today we're going to talk about SQL 2019 and persistent memory and how it can help you scale and perform. It will just be myself, not Dave won't be here. And as we go, feel free to ask questions. This is sort of kind of a highish level because I'm skipping all of the initial kind of SQL Server I/O and how I/O works in SQL Server, just to cut down on the 97 slides that we have. Okay, so if you think about your current infrastructure, think about your environment the way it is today. You know, you might be maintaining a SAN, or if you're lucky, you've got a storage administration team that looks after it for you. At the same time, we're seeing data volumes exploding, and we're not talking like 10, 20% growth a year. We're seeing growth doubling or tripling every single year. So I think we can skip the ESU just so we can, in the interest of time. There we go. So I'll talk. I will try and cover really quickly SQL Server I/O and the database structure itself. We're going to talk about storage spaces, storage spaces, and storage spaces direct, which you might imagine are the same thing, but they're not. We'll talk about caching in storage spaces direct and the differences between read and write caching, drive types, deployment options, and then your persistent memory overview. So depending on how we're doing on time, I'll try and get to the persistent memory as quickly as possible so that we can spend a good bit of time there. I'll pause there for a second just to make sure everybody's good at that. If we have, for some reason, a bunch of I/O experts, our audience is comprised of I/O experts, you can go ahead and just skip straight to the PMem, if we like. Thoughts? All right.
Up to you, Brian. Just take it wherever you want to go.
All right. I'll just go through it as quick as I can. All right. So SQL Server I/O and database, if we think about it, you know, we hear a lot about in-memory databases. SQL Server, and it's the same for Oracle or Postgres or MySQL. They're all actually in-memory databases. Everything that it does is done in memory. The smallest unit that it works with in SQL Server is a 8 kilobyte page, and you can't change that. In Oracle and some other systems, you can change the size of that. But in SQL Server, it's always fixed at 8 kilobytes, and that's going to be the smallest structure that you work with. So whether you're serving reads or whether you're modifying data, it's always done in memory. We don't modify directly on disk. Okay. We've got lots of fancy animations. I will distribute the slides afterwards for people who like to look at animations. SQL Server Disk I/O. So a typical relational database has what's called a write-ahead transaction log, Part of it's a two-phase commit, and it writes to the transaction log, and then asynchronously it writes to the data pages, and that helps us adhere to our ACID principles. Okay. Yeah, as I mentioned, reads and writes always go through the buffer pool. With disk-based operations, we use a write-ahead log. Okay. And we call the pages in memory that have been modified but not yet written to disk dirty pages. Database files and file groups. These are something that are not used often enough, in my opinion. Data files themselves, they contain all your database objects and data. Is there anywhere I can see questions if they come in, Harry?
Yeah, I will. I'm monitoring the chat, and if somebody has a question, they could put it in the chat, or they could unmute their mic and ask a question. So.
Yeah. Okay.
Preferably put it in chat, and then I can call your name, and then you can ask questions so it doesn't disrupt your flow.
I wouldn't worry about it. Just shout out. I like the open forum idea. Okay, so you your data files contain all your objects and your data belonging to your database, but strictly by convention, we have what's called a primary data file, and that has your .mdf extension. And then you can add more files that we, again, by convention, put as .ndf files. And a file group then is just a logical container for those files. So there can be multiple file groups per database. And that's what the database will interact with, is the file group. And you can add more files or remove files and so on. This can be important for some of the larger databases. You can do a thing that's called an online piecemeal restore, where you bring your primary and your hackathon or in-memory OLTP file groups online first. Plus any, like if you have like a database that's multiple terabytes, say 30, 60 terabytes, and most of it's archive sales data, but your actual sales data is quite small. You can bring that online and have the archive data remain offline, and then restore that as a piecemeal, and that way you get back up and running quicker in cases where you don't have like some kind of failover, like clustering or availability groups.
So Brian, there's a question from Randy Knight. Are you going to discuss the benefit of multiple data files for large databases, even in virtualized SAN environment? Common misconception is that the data file does not matter anymore because they're all going to the same place.
I wasn't planning to discuss it, but I completely agree with Randy. Hi, Randy. You may get told that a lot by your storage administrator. It's your SAN is just a big bunch of disks. In fact, it's not even disks anymore. It's just a big bunch of NVMe, and there's no RAID, there's no anything. But disk queuing still matters, and for the purposes of backups, threads get allocated based on mount points of drive. So these all still matter. I don't know if Randy had another point to make on this.
I think that's it. Go ahead.
Alrighty. I hadn't planned on going.
Sorry, I was trying to unmute. No, obviously, I'm old school. I've been doing many file groups for years, but I'm hearing this a lot now from customers. They'll have I've seen, multi-terabyte MDF files as a primary file. And it would be, I guess what I was looking is for some data points. If anybody knows of anything, that'd be great.
Well, I will say having being on the product group and being responsible for infrastructure as a service in Azure for SQL Server, yeah, we've seen the same, and there is a very, very concrete example of where having multiple drives helps increase your overall IOPS. So that's just one example that springs to mind. Okay.
I want to add something to that too, Brian. So this is what I've seen in our environment. We run VMware. In a virtual environment, if you stuck with one drive, usually your virtual driver for the drive can only handle so much traffic. So it is always better. I think there's a VMware best practice somewhere floating around that you can split your drive to your data files to multiple drive, and it actually gives you more performance. There you go. Yeah, multiple prior virtual SCSI driver. That's right. That yes. helps. So,
yeah, and also in the virtual case, don't forget to not connect 6 or 7 drives all onto the one SCSI adapter.
Exactly.
So
most environments are doing VMware IO totally wrong. When we go in and do health checks, almost all of them, they'll have all the drives on the LSI adapter. Maybe a pure storage array behind it, but they're bottlenecking there. So that's a good one.
As a former Pure customer, I can say that we used to call it our what was one of the devs terms. He said a magic box of unicorn blood, but it has limits. Our log file then it contains our log records. Is essentially like a kind of ticker tape of everything that has been modified, and again by convention we have a .ldf extension. Unlike a lot of databases, you can't mirror or stripe your log file. You can add multiple log files, but they will only serve as overflow or in sequence. Only one log file will be in use at a time. tempdb database is our special system database. Before I spark a holy war, is it okay if I skip past tempdb and just in the interest of getting to the actual persistent memory, if that's okay with everyone?
I think, yeah. If anybody has any objection, put it in the chat. If not, go ahead, Brian.
Alrighty. Because I'm assuming my start time is 6. Is that right?
Yes, I will. Yeah.
Alrighty. I'll be available and we'll stick around after and answer questions for as long as anybody wants. Yeah, I guess. Well, I guess we don't get kicked out anymore, so I'm assuming they run till like midnight or something. IO considerations then, regardless of platform, as we just discussed, separate logical drives between data log and tempdb, and possibly multiple drives for your data, depending on the size of your database. Multiple files per file group. Little sneaky change that came in post 2016, I believe, where we used to have that trace flag that everybody switched on, and it caused the auto growth to for all your files. If one file grew, all files grew the same, right? The nice thing about that was it applied to the entire instance. Most people only care about it from a tempdb perspective. I worked with some databases that are so busy they actually see the same kind of tempdb type contention in the user databases, and those flags don't do anything anymore. So they're essentially on by default for tempdb, but the default for your user database is to not auto grow equally. This is because a lot of customers like to kind of, fill up one file and say, all right, I'm done with that one. I'll create a new one, and then I'll let that grow to a certain size, and so on and so on. There's a setting, auto grow all files, that you can use to change that behavior, but you have to set it per file group. So if you've got thousands of databases with hundreds of file groups per database, that can be tricky. It requires an exclusive lock at the database level. So instead of just having a trace flag to cover your entire instance, you have to switch it on a per file group basis. Okay, so for infrastructure as a service, we use storage spaces to create logical partitions across multiple disks. That's different than doing it at the database file level. Okay, so you're out in the operating system there. Some of the disk considerations: your disk storage subsystem should be adequately spec'd to meet your IOPS and latency requirements. If you don't know those, you're not ready to upgrade, I would say, or to migrate, or whatever your plan is. Part of that is you should know your baselines, and you should benchmark your new hardware, or benchmark your cloud provider. So know your IOPS, and then stripe across multiple disks, as I mentioned, is a way to achieve higher throughput in any cloud environment. And then your IO optimizations, page compression is one. There is a warning or a caveat in there, in that switching on page compression can increase your CPU usage. I have found that in my experience to be practically negligible, but I'm seeing like 75% savings on disk capacity. And then also, because it stays compressed in memory, you waste less memory, and then you also, you get better page life expectancy. Instant file initialization, these are all like standard best practices. I would hope that most people are aware of. If not, we can talk afterwards, or by email, Twitter, whatever. And for high-end systems, this is somewhat semi-debatable because okay, so for high-end systems, consider innovations like in terms of we're getting this kind of convergence of memory and storage with NVMe and with new technologies like persistent memory and some of the new changes that we have come down the tracks hardware-wise. What's interesting is that our persistent memory features are not they're not gated by Enterprise Edition. So it doesn't necessarily have to be a high-end system. It will work on Standard Edition and any of the other editions we have left. So yeah, just something to consider there. There's been actually some recent debate about this, the NTFS configuration, where we typically say allocation unit size should be 64 kilobytes. That was always the maximum. And on Windows SQL Server, or sorry, on Windows Server 2019, you can have up to 2 megabytes. We haven't changed our recommendations, but I will also say that I haven't seen any white papers or anything of that nature where like this has made some like huge difference. Oh, we doubled performance by going to 64 kilobytes. Remember, this isn't the block size of your I/O. It's the cluster in NTFS. So it's not. Yeah, I would still just set it to 64 kilobytes, but do not expect that to, be the silver bullet. Certainly, if you have NTFS file encryption or compression, you should switch them off. Exception might be if you've BitLocker enabled for compliance reasons, but NTFS compression is heavily problematic. Okay, so let me see how we're doing for time. Okay, we're not too bad. I don't see questions or anything like that, so I'm relying on you here, Harry.
Yeah, so far we're good. I think everybody's doing pretty good. So if they have question,
all right,
they know the process.
All right. Storage possibilities that we have. If you go out there and you're saying, "Hey, I need some storage," we have our direct attached storage. These days, we're seeing that with the size of solid state drives, you can buy up to like 17 terabyte solid state drives now and 10 terabyte spinning Rust type drives. We're seeing less and less need for attached like enclosures to your server, but I think you can get like 2 sockets. You can get close to a petabyte of raw storage. You've got your storage area network, your SAN, Pure, for example, and you've got your network attached storage. These days, not a huge amount of difference. In the Linux world, NFS is hugely popular. NetApp is generally perceived as being, it will do block and it will do file, but generally perceived as being more of a file based or more I guess more comfortable been set up that way. So a lot of SQL on Linux admins are quite comfortable with the idea of setting up, instead of a block storage array, they mount a filer, whereas a file share for your Windows admin, generally DBAs aren't very comfortable with setting that up as their, this is where my database files will live. And then you have locally attached storage, which could be attached to the PCIe bus, which we'll talk about a bit more now in a minute. I guess we don't really get a show of hands, but is anybody familiar with storage spaces and storage spaces direct? Or vSAN if you're a VMware shop? I'll just assume there's like a whole room full of hands here, right?
Anybody who's done high IO VMs in Azure knows about them, right?
Okay. No comment. Virtual SANs are starting to become a thing. I mean, if you have any hyper-converged infrastructure, you essentially have a software SAN. So storage spaces direct, or if you buy it, you can buy it as Azure Stack HCI, where it's like gone through a certification program, but it's built into Windows as just as a regular feature. So I'll give you a quick overview. It's a software-defined shared nothing storage, and it uses the locally attached drives in the server across multiple servers to create highly available storage. So you can use RDMA. I don't know if anybody's familiar with RDMA, but you can use RDMA with NVMe. We say NVMe drives, but NVMe is actually a storage protocol. So these are actually oftentimes the same, essentially the same solid state drive. We're just not connecting them via an older protocol like SAS or SATA. We're connecting them via NVMe. And these can be super fast. And you can buy Ethernet cards, I think up to 100 gigabits a second now. And if you use InfiniBand, you can get up to like 200 gigabits a second, I think is the top. So it's quite a world away from the 1 gig iSCSI problems that people used to have. And possibly still do have, but there is a solution. It just requires money. And you can add drives, and storage spaces direct will just pick them up. Okay, so yeah, pretty much similar to any of the software SANs available out there on the market. Any questions? Okay, we'll skip. If nobody minds, I'll skip the demos again in the interest of time. And yeah, because they're coming up on 6:30. All right, not doing too bad. So new to Storage Spaces Direct, which has been around since Windows Server 2012, I think. We have dedupe for our REFS volumes. It's got native support for persistent memory. Bearing in mind, this is persistent memory operating as block storage. So it's just really fast storage with, kind of nanosecond latency. We've got, nested resiliency. You can set up clusters with a flash drive as a witness. Not sure I would recommend that in production. Scales up to four petabytes per customer. Our mere accelerated parity is twice as fast. And it can detect if one of your nodes is acting like an outlier in terms of latency. Okay. And you can even restrict the provisioning. These are all kind of standard features that you would find either on a SAN that you would purchase or on any software SAN. We haven't kind of mentioned anything that's really totally out there, except maybe the native support for persistent memory. Okay, I'm going to skip through here. All right, almost getting to the persistent memory section. Before I dive in, no questions? Or are you just going to interrupt Harry if there are questions?
Are you on mute, Harry? Yeah, we're watching the chat box and we'll let you know if there are any questions.
Alrighty, thank you. Okay, so Storage Spaces Direct has a cache option, and that's what we're going to talk about now. We'll just talk through some of the caching options. I don't know if it was it was a surprise to me that people are still buying hard disks of the spinning Rust variety. They're still out there, they're still being purchased, but then so is tape. So just to give you an idea in terms of orders of magnitude, your regular hard disk is 10 milliseconds. Solid state connected via, say, SAS is down to 0.1 of a millisecond. NVMe, depending on the quality of, if you buy like a high quality NVMe drive, something like an Optane from an Optane solid state drive, which is NVMe, you can see as low as like 10 microseconds. And then PMem, we get down into the nanoseconds. So a typical read would be like 300 nanoseconds. It can be quite surreal to be complaining about disks getting as slow as microseconds. Okay, so we have three different kind of options that we can lay out our storage spaces virtual SAN. So one is just, capacity. So we just, there's no cache. We just say, here's all our disks. We're gonna store data on them. It's actually one of the most common configurations. Then there's, you buy two types of disk, say NVMe and regular solid state. and NVMe acts as a cache for solid state. And then as a kind of a high capacity, but also highly performing option, you might say buy either high capacity solid state or high capacity hard drives, and use these almost as a third tier to provide large capacity, while your NVMe still, still acts as the cache, and then your solid state is for your warm or slightly hot data. So this is just laid out in graphical format. So when you're setting up the cache, the drives get set automatically. Bindings adjust dynamically. The read-write mix of your cache adapts to activity, and this is all independent of the files or volumes of the storage pool. So it just works and behaves like magic. So we're told. Okay, so, and of course handles failures. And this is probably the main upfront big decision you have to make, right? How many nodes am I willing to tolerate failure of? We see a lot of configurations where SQL Server is running on the same box. So reads are served locally, and then they're using storage spaces direct for redundancy. Okay. There's also write caching, which we typically don't like in SQL Server. One of the maxims, or one of the axioms of SQL Server is that we expect stable media, right? So once something has been written, we expect it, to stay written. We don't expect an intermediary cache to say, hey, maybe I wrote this, maybe I didn't. Okay. So for anybody using hard drives, random IO, of course, as we know, is hard for hard drives, and a write cache can absorb bursts and keep working steadily, so that you see consistent performance even if your load is variable. Okay, read caching. As we know, Flash is faster. Sorry for powering through here a little. Okay. So SQL Server 2019. So these are all those supported platforms for persistent memory, right? We have Windows Server 2016 and 2019. I will say that Windows Server 2016 is extremely popular still. So even during upgrades, we see customers choose Windows Server 2016, and it's only supported for what's called memory mode, or 2LM, so like almost like an additional cache of memory. So it's not directly supported for the features that are built into SQL Server 2019. I'll talk a bit more about that in a second because I'm aware it is kind of confusing. Yeah, and then from 7.3 up on RHEL, SUSE from version 12 and up, Ubuntu 16 and up, and Docker Engine 1.8. So we keep all these reference. And the storage that we support is the same as we support for any data files. It's XFS and ext4. And with forced unit access. Okay, finally, with some minutes to go, we've got the persistent memory. Any questions, comments, shout outs so far?
Yeah, nothing in the chat.
I think we're good. Yep.
All right.
Keep going.
All righty. Okay, so first we'll talk about what persistent memory is, how you configure it, what are interleave sets, which is something you may hear mentioned, and then replacing it if it fails, because anyone who's been around and has used servers and technology has definitely seen memory fail. Okay, because these and this is why we're kind of like all the way through the deck. We're showing images to really let it sink in that this doesn't look like a normal drive, right? It basically looks like a standard memory DIMM with this heatsink essentially on it. If you go online, websites like Served Home, they take off the heatsink and kind of tinker around and show you what's underneath it. Pretty sure that voids your warranty, so I would check it out on the web rather than do it yourself. So as we know, hot data and cooler data and our access frequency. This is going to lead up to, if anyone has seen any presentation from Intel, with apologies to any Intel members in the audience. If anyone has seen any presentations from Intel in the past year or so, they will have seen this, the pyramid of storage. So we have our cold tier moving up into solid state, which is our warm tier. And apparently there was a gap, and into this gap, coincidentally enough, fits Optane. So we say Optane, and people generally mean the persistent memory, but there's actually the same technology is used for solid state as an NVMe drive. Compared to NAND, which is what solid state typically uses, there's better write endurance and more consistent and slightly lower latency. Okay. So here we go. So here are our modules. It's based on 3D Crosspoint technology, which is co-developed with Intel and Micron, and comes in 3 flavors: 128 gigs, 256 gigs, and 512 gigs. And we are very hopeful that this capacity will continue to grow. if you have a lot of influence at Intel for some reason, please put some pressure on there. We would love to see much larger capacity sizes than even this. And then on the other side, on the NVMe side, these are NVMe cards. One of the big differences between the Optane 3D Crosspoint based kind of PCI cards and NAND based PCI cards is around capacity. So the NAND drives, I've seen 17 terabyte drives that you can buy. These Optane drives, the largest capacity you can buy is 1.5 terabytes. So, you know, there's a limited number of PCIe slots on your server. So that can be an issue if you have really large databases and you want to store them all on local storage. Okay, so persistent memory. So this is kind of new. We say it's a new memory technology, but then everybody I talked to who's working on it has been working on it for like the past decade. So it's been around a while. But we're starting to see it enter that adoption cycle. We're kind of in that first phase of the adoption cycle. And essentially what we're talking about is a type of non-volatile RAM. So we've had it so long in computing, we're very comfortable with the idea of this kind of fast but volatile storage area. And then this slower, durable storage area that's not volatile. So sometimes it's referred to as storage class memory. I see that as almost a philosophical difference, but it's a philosophical difference that can matter in a way. Some would say that Optane is kind of storage brought to memory, and there are other types of persistent memory, such as NVDIMM-N, which are regular memory DIMMs, and they're kind of like backed by a capacitor, and they write to NVMe. And these are considered, or could be considered, as more durable memory. Again, as I say, we don't take a position on it. We support all the persistent types of all the types of persistent memory that are out there, and yeah, I see it as a almost philosophical difference. They fully supported with Windows Server 2019. And I will say, to take advantage of features like hybrid buffer pool in SQL 2019, you do need Windows Server 2019. So it's I know we've had features like this before, but it is very tightly coupled with the operating system itself. So it's something to be aware of. To give you an idea of the kind of performance and scale that we can hit, we've got this is, I think, a 12-node cluster running TPCH benchmark, and using HammerDB, and we saw 10 million IOPS, and we're still in the microsecond range, which is pretty impressive. They're the benchmarks. As you can see, these For analytical type workloads, this is extremely exciting. If you use a lot of Columnstore, you may be aware that the read-ahead size for Columnstore is quite large. It's actually can be up to 8 megabytes in size. So these kind of large sequential reads are quite exciting. Okay, so hopefully not jumping around too much. DAX just stands for direct access. I will use that interchangeably with app direct, but essentially it's bypassing the memory on your server, and your application is skipping the kernel entirely and just writing directly to persistent memory. Hence the direct access. And that's how hybrid buffer pool works. Yeah, and it can, because SQL Server, which runs in user space, or can stay in user space for longer, there can be considerable gains from that. And you don't have all this interrupt and switching between kernel mode and user mode. No questions on that? All right. When you're configuring this, don't use the GUI. You have to set a flag that says is DAX in Windows, and that essentially lets it know that the drive can be used for direct access. We call this persistent memory aware file systems in Linux. It's called file enlightenment. I have received quite a lot of flack around this. There's not a huge difference. This is not some major favoring of Linux over Windows, but the how file enlightenment is performed is the same operation. It's stacks, and we just found through testing and benchmarking that the gains in Windows were negligible. There's a lot tighter binding between the kernel and user space. And what happens when you start up SQL Server is it detects that you're using persistent memory, sees the files that are on there, and then it memory maps those files for SQL Server to issue load and store and flush type instructions, essentially behave like a processor, and performs no I/O, bypassing the I/O stack completely. Yeah, so you can configure this for Linux or Windows for hybrid buffer pool. The difference on Linux for data file enlightenment is essentially, if for some reason you didn't want hybrid buffer pool, you could still have the DAX behavior on the data files. We don't recommend that the log file be used on these, because to use DAX, you can't use any kind of RAID or mirroring or striping or anything like that. Quick overview of SQL Server 2019. We have what we're calling like in-memory features. So these encompass what you already know and love, and also some new features. So we have our memory optimized tempdb metadata, which does not require PMem, but it uses in-memory OLTP, and it creates the system tables in tempdb as in-memory OLTP tables, and that can alleviate a very specific type of contention on those tables. We have our persisted log buffer, aka tail of log cache, which is actually released in SQL Server 2016 Service Pack 1, I believe. I see something flashing. I don't know if that's
we have a question.
Sure.
From Eugene. Says, if I have a byte addressable memory that survives shutdown, then I don't need file system, correct?
Okay, say that to me again. If you have a byte addressable
memory that survive shutdown, then I don't need file system, correct?
Well, you don't technically. I'm gonna get in trouble for this. Technically, you don't need a file system for SQL Server at all. It will work with raw volumes. I wouldn't recommend it. I don't think as a DBA you'll have a fun time, but it is support. Raw volumes are supported. What is not supported is the use of DAX and raw volumes. So ironically, you do actually need a file system, a persistent memory aware file system. Does that help with answering your question?
Thank you, yes.
Yeah, okay, thanks.
5 minutes warning.
Oh man, 5 minute warning. Oh man.
Yeah. We have time. I mean, go ahead.
Okay. So that's persisted log buffer. We have our data file enlightenment that I mentioned. That is our only one that is Linux only. Hybrid buffer pool and in-memory OLTP, which we still all call Hackathon. Because in-memory OLTP is quite the mouthful. So as I say, consider this something of a feature family that we'll continue to add to over our next few releases. But this is what we have in there in that grouping currently. The ones in green are the new ones. I'm including persistent log buffer as new, because it wasn't documented before, and B, because we brought it to SQL on Linux as well. With special thanks to Bob Ward for putting this together, because this particular diagram, I think, explains how it all works much better than any of my strained explanations to Bob before pass, as he concentrated on his 7th talk and was like, how does this work again? So as you see, you can use this as a block device, calling the regular OS file APIs, and it behaves like really fast storage at that point. We have our persisted log buffer, where it persists the 20 megabyte buffer that gets flushed to the write ahead log, and because that gets persisted, essentially you get that kind of delayed durability async behavior, because we know that as soon as we write to the buffer, it's durable. Then we have our enlightened IO, which, as you can see in this diagram, bypasses the kernel. And then we have our buffer pool, hybrid buffer pool, which is actually well, sorry, hearing some noise. All right, I'll ignore that and just keep going. Which is actually the first time that we've had more than one buffer pool in SQL Server. Is hybrid buffer pool. So just interesting factoid there. Okay, since I'm assuming we only have about like a couple of minutes left, this is your persisted log buffer. They're all in the docs, and as I say, works with Windows and Linux now. The main caveat to be aware of with this is that in an availability group, this only works on the secondaries, which for a lot of folks, it means it's considerably less useful than they would like. The Enlightenment database files, as I mentioned, it needs to be a persistent memory aware file system, and this is performed through SQL PAL, our platform abstraction layer. And the main benefit here is that we've no involvement of the kernel. So reduced latency, reduced number of CPU instructions, longer time in user space or user land. It's our hybrid buffer pool, which is the main feature around this, and what we will continue to expand over the coming releases. So it's essentially your persistent memory acts as your buffer pool and your storage at the same time. There's no copy operation needed from storage to your buffer pool. Your buff structure is essentially just a pointer to the persistent memory. The benefits of that should be obvious. Frees up DRAM for further needs and eliminates IO and all that good stuff. Okay, I think I'm going to stop there, just in case you have any questions. And also because I typically get accused of running over time. So
no problem. If anybody have questions,